July 20 to 5. At first, no one thought much of it, just another faint smudge in the night sky. Another anonymous visitor cataloged and forgotten. But what started as a routine observation in Chile would soon become the most unsettling astronomical mystery of the century. The alert came in just after midnight from the Atlas telescope at Rio Hurtado, a small moving dot, fast, bright, uncatalogued. Within minutes, the system flagged it as unusual. Its motion didn't match any known asteroid or comet path. The numbers were off. When the first orbital data dropped, the results hit like a shockwave. The object was tearing through space at 135,000 miles per hour, an impossible velocity for anything born inside our solar system. The calculated orbit wasn't elliptical, it was hyperbolic, meaning only one thing: this object was not from here. A few years ago, names like Oumuamua and Borisov had already hinted that interstellar travelers could drift into our neighborhood. But this one was different. This one wasn't drifting, it was driving. They called it 3I ADLAS, the third confirmed visitor from the stars. And from the first moment telescopes locked onto it, nothing about it made sense. Across observatories, Slack channels, and late-night labs, astronomers scrambled to analyze the incoming data. Each new observation only deepened the confusion. Its trajectory was too precise, slicing through the solar system almost perfectly along the ecliptic plane, just 5 degrees off Earth's own orbital path. Objects from deep space don't move like that. They come in high, steep, chaotic. But 3I Atlas glided as though it knew where it was going. Its orbit would carry it between Earth and Mars by late October. No danger to us, but impossible to ignore. Within hours, telescopes from 3 continents were turned toward the strange traveler, racing to capture images before dawn. And then, the first real shock arrived. On July 21st, Hubble's imaging team logged their first deep exposure. The scientists expected to see what they'd seen countless times before: a comet tail stretching away from the sun, driven by solar wind. But when the raw images loaded on the screen, the room went silent. The tail was pointing toward the sun, not away, toward a sunward jet, narrow and unwavering, like a beam of vapor locked on target. Every instinct told them it had to be a glitch, a reflection, a calibration error. But when they checked again, the anomaly remained. Gemini South confirmed the same pattern. So did instruments in Hawaii and the Canary Islands, across multiple nights and viewing angles. The plume stayed steady, burning straight at the sun like a cosmic engine. It made no sense. By every rule of physics, sunlight should have pushed that dust tail away, not drawn it in. The team recalibrated filters, cross-matched with Gaia's star catalogs, and eliminated background noise. But the data refused to budge. The jet was real. And then came the second shock. When precise tracking data came in from Hubble and Gemini, the numbers revealed something chilling. 3I ADLAS wasn't following a purely gravitational path. Every new measurement showed a tiny extra acceleration, a subtle push that couldn't be explained by sunlight, gas jets, or radiation pressure. It was being nudged. The acceleration was small, about 410 meters per second squared, but consistent, always in the same direction as the jet pointing toward the sun. It was as if the object was propelling itself. Jet simulation experts ran the math. To generate that level of thrust, the object would have to expel over 300,000 kilograms of material every second, equivalent to the exhaust of a small rocket engine. But when astronomers analyzed the coma, the cloud of gas around the object, they found a total mass loss of barely 1 kilogram per second. The numbers didn't match. The thrust was there, but the fuel wasn't. Every comet in our solar system releases dust and vapor under solar heat, a chaotic, random spray. But 3I ADLAS's plume was surgical, targeted, and sustained. Whatever was powering it, it wasn't ordinary sublimation. And then the James Webb Space Telescope joined the investigation. Under the leadership of Dr. Carrie Liss, JWST's near-infrared spectrograph dissected the chemical makeup of the comet's halo. The readings made even the veterans of the field question what they were seeing. Carbon dioxide in staggering quantities, 8 times more than water vapor. No comet had ever shown that ratio before, and stranger still, Webb detected nickel without iron on Earth. In meteorites, even in the cores of planets, nickel and iron always come together, bonded in twin abundance since the birth of the solar system. Finding one without the other shouldn't be possible, yet the spectral lines were clear. The nickel signal was sharp, unambiguous. Iron was missing. The team ran recalibrations. Then they ran them again. The anomaly held. If the data were right, and all signs said it was, the object wasn't just behaving unnaturally. Its very composition was unnatural, somewhere between the numbers and the silence of deep space. A question began to take root. One no scientist wanted to say aloud, was 3i ATLAS alive? Or worse, engineered? Because if it wasn't random, if that precision wasn't chance, then something out there was deliberately flying straight into our sun. And that was a thought humanity wasn't ready for. By late August, the mystery had grown beyond the realm of astronomy. Every new data point only deepened the strangeness. At Harvard Center for Astrophysics, orbital analysts fed the latest trajectory into their Monte Carlo simulations. Millions of virtual test runs meant to model every possible interstellar approach. What came back was staggering. The odds that a random object from deep space would slip into our solar system, just 5 degrees off the ecliptic, weaving neatly between Jupiter, Venus, and Mars, were less than 1%. Interstellar objects aren't supposed to do that. They come in at steep angles, cutting through the planetary plane like stones skipping off water. But 3i Atlas was gliding almost perfectly flat, a path so aligned, so deliberate. It looked planned. The comparison to 2017's Oumuamua was immediate. That earlier interstellar visitor had baffled scientists with its strange acceleration. But it showed no tail, no plume, just a dark, tumbling shard slipping silently through sunlight. 3.1 ADLAS, however, was the opposite. It was alive with motion, a bright beacon advertising its presence to the entire solar system. As if it wanted to be seen, theorists, SETI researchers, and planetary dynamicists filled live streams, podcasts, and midnight panels with speculation. Was this a cosmic coincidence or a signal? Some insisted it had to be random, a fluke of celestial mechanics. Others saw something different, a pattern that felt too intentional. The sequence of planetary flybys looked like a maneuver, each world positioned along its course like stepping stones. As one commentator put it, if you wanted to announce yourself without being intercepted, this is the path you'd take. As October 30th, 2025 drew closer, a quiet tension spread through observatories worldwide. 3.1 Atlas was about to pass behind the sun. Once it did, every telescope on Earth, even space-based instruments like Hubble and Webb, would lose sight of it for weeks. The blackout was unavoidable. Inside NASA's mission control, screens glowed with final data. Engineers coordinated the last imaging runs, desperate to capture every photon before the signal vanished into solar glare. You could feel the anxiety in the air, a mixture of exhaustion, awe, and something that felt almost like fear, because when the object went dark, so would our understanding? If its path changed while hidden behind the sun, no one would know until it came out the other side. And by then, it might be too late to explain. As the final transmissions rolled in, astronomers watched the object fade from visibility. The jet still burned, a narrow beam of light directed toward the sun. Then, like a candle snuffed out, it was gone. And silence fell. For the first time in months, the world's most powerful telescopes had nothing to look at. But humanity couldn't stop watching, or wondering. Speculation exploded online. Some researchers revisited the concept of the Bracewell probe, a theoretical autonomous sentinel, designed to drift through space until it detects intelligent life. Could 3i Atlas be one of them? A machine waiting to see who notices? Others went further. They pointed to the object's nickel-rich, iron-free composition, the bizarre 8:1 carbon dioxide ratio, and the sunward jet as evidence of a deliberate process, maybe even terraforming material, slowly dispersing across the inner planets. And then came the darker theories, the kind that keep you awake at night. A few physicists proposed the dark forest debris hypothesis, the idea that 3i Atlas might not be a probe at all, but wreckage from a cosmic war, drifting endlessly with a damaged engine still sputtering. Unaware that its creators are long gone, the discussions were everywhere. Late-night talk shows, Reddit threads, news panels. Everyone had a theory, but no one had proof. Because until the object re-emerged from behind the sun, the data stream was blank. The entire world was left in cosmic suspense. Weeks passed. The blackout stretched on. And then, in early December 2025, the first faint signal returned. At first, it was barely a whisper, a tiny flicker in the darkness picked up by an optical array in Hawaii. Then another, stronger signal from the European Southern Observatory confirmed it. 3.1 ADLAS was back, but something had changed. Its brightness had shifted. Its trajectory, too, just slightly, but enough to trigger alarm. Early models showed a minute deviation, one that couldn't be explained by gravity alone. The world once again turned its eyes upward. The James Webb Telescope locked on for new readings. Its spectrographs confirmed the same alien chemistry as before, the carbon dioxide dominance, the lonely nickel lines. But this time, there was an additional anomaly, a faint but rhythmic pulse in the brightness curve. Every 4 hours, a soft modulation repeated, almost like a heartbeat. Coincidence? Instrumental noise? Or something transmitting through light? The data was too thin to say for certain, but the possibility lingered in every conversation. What if it was deliberate? By now, the debate had left academia. The question had reached the public consciousness. News anchors spoke of it as the object that breaks physics. Social feeds filled with speculation. Was it a probe, a seed ship, a lost relic? Yet among scientists, one phrase echoed louder than any other, whispered half jokingly, half in dread. What if it's watching us back? Because of 3i, Atlas had changed course even slightly while hidden behind the sun. It meant something. Someone had adjusted it. NASA and ESA teams remained cautious. They refused to label it artificial. But behind closed doors, you could sense it, a quiet realization that humanity might be witnessing its first undeniable encounter with technology from another star. For now, 3.1 ATLAS remains the most perplexing interstellar visitor ever recorded, a mirror in the dark, reflecting our deepest hopes and fears back at us. It defies gravity, rewrites chemistry, and moves with purpose in a universe that should be random. And as it drifts farther from the sun, growing fainter each night, one haunting question lingers across every control room and Midnight Skywatcher's heart.